Hi everyone. This video is meant to go along with the 5-5 note sheet part 1, and if you haven't already opened that up, you're going to want to do that before you continue with the video. This first work module is essentially going to cover section 5-5. So 5-5, it's still in chapter 5, it's still all about eigenvalues and eigenvectors, but in this section we're going to have complex eigenvalues. And complex, you might not have dealt with this since algebra 2-ish, but this is where we're going to have imaginary numbers coming into play. So as a reminder, we're going to be working with the number I, and I is the square root of -1. So if we have something like the square root of -4, we can simplify that to 2i. And we're going to be doing stuff like that a lot in this section. So the key is that anytime we are looking for eigenvalues, we end up using the characteristic equation of that matrix. And sometimes the characteristic equation is not going to have real solutions. So if it's of degree n, it should have n roots. But so far we've only been dealing with eigenvalues that were real, and most of them were integer values. Actually, they might have all been integer values. But for this, we're going to start having imaginary stuff. So this first worksheet is all about finding the imaginary or the complex eigenvalues and eigenvectors, and then the other video for 5-5 deals with what their application is going to be. So first of all, we are going to just walk through a couple problems together. We're going to first find the eigenvalues of this pretty nice matrix. If you remember, and we did a couple eigenvalue problems in the Zoom lesson yesterday. So we are looking for where the determinant of a minus lambda I is equal to 0. So if we find, it's a minus, so if we find a minus lambda I, we're going to have this matrix, 0 minus lambda is minus lambda, -1, 1 minus lambda. And we're setting that equal to 0. So if we find that determinant, we're going to have lambda squared minus a -1, so plus 1 equals 0. Lambda squared equals -1. So lambda is going to be plus or minus the square root of -1, which is plus or minus I. And those are going to be our eigenvalues. So we're going to start with finding eigenvalues, and then we're going to be finding eigenvectors later in the packet. So I would like for you to try to take a minute, pause this video, try number 2. To give you a heads up on number 2, you are going to need the quadratic formula. And so first test yourself, do you remember the quadratic formula? But give number 2 a try, pause this video, try number 2, and then I'll go over it. With number 2, so if we set up our problem, we should have 0.5 minus lambda, -0.6, 0.75, and 1.1 minus lambda equals 0. Oh, the answer ends up being 0.8 plus or minus 0.6i. So if you got that, you can skip the explanation, you can just go, you can skip forward in this video a little bit and move on to the next set of problems. If I simplify this, so if I multiply minus -0.6 times 0.75. So when I simplify this, I got this for my equation, lambda squared minus 1.6 lambda plus 1 equals 0. And then using the quadratic formula, I got my eigenvalues of 0.8 plus or minus 0.6i. So if you didn't get any of these key steps along the way, just retry the problem and see if you can get the right answer on your second try. So this would be a good time to pause the video and try numbers 3 and 4, and I will go through them in just a minute. So first pause the video, try them on your own, and then come back. For number 3, I did not get imaginary eigenvalues. So for number 3, I got 7 and 1. So if you got 7 and 1, you can skip the explanation, but it's going to end up having the equation lambda squared minus 8 lambda plus 7 equals 0, which factors nicely. But for number 4, I did get imaginary eigenvalues, and again, I had to use the quadratic formula to get them. My answers are 4 plus or minus 3i. So again, if you got that, you can skip ahead in the video. With this, I had the characteristic equation lambda squared minus 8 lambda plus 25 equals 0, which I used the quadratic formula for, giving me lambda equals 8 plus or minus square root of 64 minus 100 all over 2, which simplifies 8 plus or minus the square root of negative 36. The square root of negative 36 is 6i, and it's going to simplify. 8 over 2 is 4, 6 over 2 is 3. Okay, so if you didn't get those, try again. Otherwise, you can move on. Okay, so one thing that we can do is, this is just kind of neat. If we switch the sign of one entry in a 2x2, we can go from something that has real eigenvalues or something that has imaginary eigenvalues, depending on the situation. So for example, on this problem, so if u is 5, 2, 4, 3, if I change this entry, instead of being a positive 2, if I make it a negative 2, and I'll give it a new name, 5, negative 2, 4, 3. And if I find the eigenvalues of this matrix, I am now going to have things that are imaginary. So if I set up 5 minus lambda, negative 2, 4, 3 minus lambda. And if I cross multiply and simplify, I'm going to get lambda squared minus 8 lambda plus 23. And you can always pause this video and verify that on your own. So that's going to give me the square root of negative 28 in the quadratic formula. You'll notice for these problems with imaginary solutions, we're typically not going to be able to factor. We're really going to have to use the quadratic formula quite a bit. That also means that we're going to work mostly with 2x2 matrices, because finding imaginary roots on a larger matrix can be kind of a pain. But you'll find out in the next section sort of the application of using these with a 2x2, what that's going to look like. But anyway, 8 plus or minus, what's that? That's 2i root 7 if I simplify the square root, because 28 is 4 times 7. 4 plus or minus I root 7. So you'll see that I just changed the entry of the top right value, and what I'd like for you to do is take a look at the next problem and pause this video, try it on your own, see if there is an entry in this matrix where if you just change its sign, like positive, negative, you'll be able to get, on this one, you'll be able to get real solutions. If you notice that the matrix for number 7, is the same one as number 4 from earlier in the worksheet. And on number 4, we found imaginary eigenvalues. So for this one, we want to change it so that we have real eigenvalues. So pause this video, give it a try. So here's my solution. I again changed the top right entry. So if I made it 4, -3, -3, 4, we get something that's pretty easy to work with. If I find minus lambda, -3, -3, 4, minus lambda. For this equation, I got lambda squared minus 8 lambda plus 7. I feel like we already did this. Oh, it has the same characteristic equation as number 3. Oh, that's interesting. So anyway, we find that this factors. And we get our 2 solutions. For the next set of problems, we're going to be finding our complex eigenvectors that go along with these